It's really not needed today. The countdown has been going very, very smoothly ever since it was picked up, and we are looking forward to a launch on time at 1:30 p.m. Eastern Standard Time. On the pad, the ICE team is in the process of taking a look at the vehicle on the zero level of the MLP, or the Mobile Launch Platform. The team is made up of 4 people who go up to the deck, or zero level, to the 195-foot level where the orbiter access arm is, and to the 215-foot level, which is at the top of the external tank. While they're on the Mobile Launch Platform, they will also look up into the engine area to ensure that no ice is built up on the engine gimbals or other areas. At the conclusion of their inspection, they'll return to Firing Room 2 and report to Launch Director Al O'Hara. They are looking for ice that might build up on the external tank because of the super cold liquid hydrogen and liquid oxygen inside. The only danger is that that ice would shake off during launch and possibly damage the rather fragile thermal protection system, or the heat-resistant tile on the orbiter. Also on the pad at the present time is the support crew, which is preparing the white room and the crew compartment for the flight crew to enter the orbiter. At the present time, they're in the process of checking the oxygen level inside the cabin. This is essential because during the tanking of the cryogenic propellants, gaseous nitrogen is flowed through much of the vehicle to ensure that there is no possibility of an accumulation of any flammable vapors. Everything going smoothly in the countdown, T-minus 3 hours and holding. This is shuttle launch control. Launch control. This is shuttle launch control at T-minus 3 hours and holding. We have approximately 25 minutes remaining in this hold time. The astronaut prime crew is presently in the breakfast room and prepared for breakfast. They have been joined by a number of other astronauts at the various tables. At the head table is the pilot Carol Bobko, sitting beside Dr. Story Musgrave. Pilot Carol Bobko, Dr. Story Musgrave, Commander P.J. Weitz, Paul Weitz, and Mission Specialist Donald Peterson. It's somewhat of a traditional breakfast for the astronauts this morning. They have a choice. All of them have decided on orange juice. They have a choice of eggs or cereal or steak, or a combination of that. Joining the crew this morning for launch are some of the support astronauts, James Van Hoften and Woody Spring, Anna Fisher, Kathy Sullivan, Sally Ride, who will be on the STS-7 mission is also present. At the other table, Lieutenant General James Abramson, who is the Associate Administrator for Space Flight at NASA headquarters and ultimately responsible for the mission. The crew getting ready to be served their breakfast. Back on the pad, the closeout crew is in the process of completing their preparations in the crew compartment for the astronaut crew to come out to the pad and enter the vehicle. There's a number of tasks which must be performed in the crew compartment. One of them is taking out everything that is not needed during the mission. Although this is a 4-man mission, and we will have as many as 7 crew members on future missions, the area is not large enough to be leaving any excess material in there. The solid rocket booster recovery ships are presently in the area of the proposed splashdown for the solid rocket boosters. They departed from Cape Canaveral yesterday approximately 5 p.m. and arrived in the recovery area about 5 a.m. this morning. They're in the process of doing a sweep of the impact area, which is located approximately 100 from picking up the countdown at the T-minus 3-hour point. Everything has been going very smoothly during this hold period. As a matter of fact, during the entire countdown, a 93-hour countdown leading to liftoff of STS-6 at 1:30 p.m. Eastern Standard Time today. It's about 5 seconds away. And we're T-minus 3 hours and counting. There's just 2 other built-in holds in the countdown which remain. A 10-minute built-in hold which comes at the T-minus 20-minute point, and a 10-minute built-in hold at the T-minus 9-minute point. The countdown going very smoothly. The clock at T-minus 2 hours, 43 minutes, 30 seconds and counting. This is shuttle launch control. This is shuttle launch control, T-minus 2 hours, 36 minutes, 38 seconds and counting. The flight crew is just in the process of leaving the crew quarters in the O&C building and is in the elevator ready to go down to the first floor, with the exception of Story Musgrave, who has just run into the elevator and been greeted by Don Peterson, the other mission specialist. John Young among the group, and they're just about to close the door and will be on their way to the ground floor and the Astrovan, which will take them to the pad. Commander Paul J. Weitz, who is the leader of this mission, has been an astronaut with NASA since 1966, and he served as a pilot on Skylab 2, the first manned Skylab mission, spending approximately a month in orbit. He was born in Erie, Pennsylvania, and has degrees both from Pennsylvania State University and the U.S. Naval Postgraduate School. They're on their way now out of the door of the O&C building. Commander Paul Weitz waving to the crew, entering the Astrovan along with the mission specialist. Carol Bobko went over and shook hands with somebody who wished him well on their trip. The van being closed up by the security chief for this particular job, Gene String, and they're on their way to the pad, and they launch on time at 1:30 p.m. Eastern Standard Time this afternoon. This has been an exceptionally smooth countdown ever since it picked up. A 93-hour countdown, which was picked up on Wednesday afternoon and proceeded up to Saturday night at midnight. There was a 24-hour, 10-minute hold over Easter Sunday, and then it was picked up at 10 minutes after 12 this morning, and has been proceeding smoothly ever since. The only concern has been a weather concern, and there is continuing analysis of weather balloon data, which we should probably receive about the T-minus 50-minute point. However, a management decision was made about 9 o'clock this morning that we were go for launch with the upper level winds. Everything going smoothly, the countdown clock at T-minus 2 hours, 34 minutes and counting. This is shuttle launch control. Reached the white room on the orbiter access arm and are preparing for their entry into the crew compartment. The NASA test director has asked that the orbiter test conductor conduct a checklist of all of the engineers monitoring those systems and determining that there's no violation of launch commit criteria prior to allowing the astronaut crew to enter the crew compartment. Commander Paul Weitz and Carol Bobko in the process of putting on their harnesses. Carol Bobko joined the NASA's astronaut corps back in 1969 and was a crew member of the highly successful Skylab Medical Experiments altitude test. This was a 56-day simulation of the Skylab mission, enabling crewmen to collect medical experiments baseline data and evaluate equipment. He also was a support astronaut for the Apollo-Soyuz test project and served as a lead astronaut in the test and checkout group at the Kennedy Space Center on the first flight of Space Shuttle. Carol Bobko is considered by the people at the Kennedy Space Center to be an honorary member of Kennedy. In the process of putting on his Snoopy hat and his launch and entry helmet, which is a hinged helmet that is placed in place and then locked around the neck, makes a seal for the launch and entry to provide both communications and life support functions. In the past, when the spacesuits were used during the launch and re-entry phases, the helmet locked to a ring on the top of the suit, but now a different sort of device is being used. Everything going smoothly in the countdown. I've had a report from the support astronaut that the switch list of switches inside the orbiter has been configured for entrance of the prime crew into the crew compartment. And Commander Paul Weitz, or P.J. Weitz, has entered the crew compartment at present in the orbiter, preparing for launch, which we expect to be on time at 1:30 p.m. The countdown going smoothly. The clock at T-minus 2 hours, 13 minutes, 8 seconds and counting. This is shuttle launch control.
OTC, close out crew. Go crew. Okay, commander and pilot are being ingressed at this time. Thank you, sir. And OTC from ASP to caution, warning clear is complete. Thank you.
The mission specialists for STS-6 are presently in the White Room, getting ready for their entrance into the crew compartment of the Orbiter Challenger.
Copy, flight control.
Mission specialist Donald Peterson is a retired colonel of the Air Force. He's also a graduate of the U.S. States Military Academy at West Point and has a master's degree in nuclear engineering from the Air Force Institute of Technology. Peterson joined NASA back in 1969 and served on the astronaut support crew for Apollo 16. His main areas of responsibility within NASA have included engineering support, man-machine interface, and safety assessment. He's in the process of hooking up his harness. Actually, the harness that the astronauts are wearing is used in case of an emergency, and there are two parts to it. One is an integrated harness and egress sling, which would be used for exiting from the orbiter in the case of an emergency landing. The other portion is called the personal egress air pack and provides oxygen where they would have a contaminated atmosphere. This differs from the harness worn during previous flights because for the first time, operational type seats are available in the orbiter. The Columbia, which had flown on the first 5 missions, had been configured with ejection seats for the test program and with temporary seats for the mission specialists. With the Challenger online, we've moved into an operational type seat for the entire onboard crew. Also getting ready for his entrance into the orbiter is Dr. Story Musgrave. He has biomedical sensors attached to his head, which are part of the ongoing program in looking at the cause of motion sickness in space. Dr. Musgrave is a medical doctor in addition to having degrees in mathematics and statistics, business administration, and computer programming, chemistry, physiology, and biophysics. He was selected as a scientist astronaut by NASA back in 1967 and worked on the design and development of the Skylab program. He was the backup science pilot for the first Skylab mission and was a capsule communicator for the second and third missions. Dr. Musgrave participated in the design and development of all of the Space Shuttle extravehicular activity equipment. During his period with NASA, he has also kept up his clinical and scientific training as a part-time surgeon at Denver General Hospital. He's an accomplished parachutist and has made over 300 free falls, including 100 experimental free fall descents involved in the study of human aerodynamics. The countdown going very smoothly. Some of the activities which the pilot astronauts, Commander Paul Weitz and Carol Bobko, would be going through once they've gotten into their seats, gotten the seats adjusted, will be to begin their communication checks with the control center here at Kennedy and also at Mission Control in Houston. Mission Specialist Don Peterson taking a look inside and is just about to enter the orbiter. The countdown clock at T-minus 2 hours, 7 minutes and counting. This is shuttle launch control. Five minutes and counting. Dr. Story Musgrave is in the process of donning his entry and launch helmet and preparing for his entry into the crew compartment on board Challenger. And Don Peterson, the other mission specialist, will be the next to put on his helmet. The ground launch sequencer computer program has been started. That will actually be placed online at the pickup of the countdown at the T-minus 9-minute point. The solid rocket booster rate gyros have been turned on, and a gaseous nitrogen purge of the solid rocket booster aft skirt has begun. The rate gyros are used by the orbiter navigation systems to determine the rate of motion of the solid rocket boosters. During their 2 minutes of flight, the simulation of the first motion of the shuttle has been sent to the Johnson Space Center Range Safety and Firing Room to test the system, which indicates liftoff. This signal also starts the clock, which keeps track of the mission time. Everything going smoothly in the countdown as we look forward to launch at 1:30 p.m. this afternoon. Dr. Story Musgrave making some final adjustments of the cabling which is attached to the various sensors on him, biomedical sensors which are used in the study of motion sickness in space, and will be entering the orbiter shortly. Unlike previous flights aboard the Columbia, all 4 of the astronauts will be able to sit on the flight deck during the launch and the re-entry. The countdown clock continuing at T-minus 1 hour, 53 minutes, 3 seconds and counting. This is shuttle launch control.
Flight controls, OTC. We have a hack on when we might pick up with the reconfiguration? In 2 or 3 minutes. All right. OTC, GLS 212. GLS. Yes, GLS.
This is shuttle launch control at T-minus 1 hour, 40 minutes and counting. At the present time, 3 of the 4 crew members have entered into the Orbiter Challenger and are in the process of preparing their particular area for launch. Commander Paul Weitz and pilot Carol Bobko have been in the process of making sure that their seat height was adjusted, the rudder pedals were adjusted, and that the pitch knob was tight, and then have checked their ascent cue cards and checklists and attached the tethers. Mission specialist Dr. Story Musgrave has also entered the crew compartment, and he is in the process of getting himself settled in his seat as well. In just a short time from now, Mission Specialist Don Peterson will also be entering the orbiter. He has been in the process of attaching his harness, and next will be putting on his launch and entry helmet and then moving into the crew compartment. As soon as all of the tasks, sort of the housekeeping tasks, have been completed, then the support astronaut will be removing a number of items from the crew compartment. They include such things as the personal equipment transfer bag, the launch and entry helmet visor protectors, the various checklists, inspection mirrors, pin lights, the mid-deck floor covers, the reaction control system and OMS engine switch guards, and the flight deck protective flooring. These are things, some of these are things which protect the surfaces of the orbiter from any damage that might occur from people walking on them while the orbiter is in a upright position during and in a 1G environment. Of course, when it's in 0G, there's a much lighter touch as the astronauts move around the crew compartment. And now Mission Specialist Don Peterson in the process of putting on his launch and entry helmet, and then we'll be moving into the crew compartment. Everything going very smoothly in the countdown. The next step will be communications check with the firing room and air-to-ground voice circuits between the commander, pilot, and the mission specialist. The countdown clock continuing, T-minus 1 hour, 37 minutes, 16 seconds, and counting. This is shuttle launch control. And the hatch on the Orbiter Challenger has just been closed. The hatch was closed by the technicians in the closeout crew in the White Room after the NASA test director talked to Commander P.J. Weitz and asked him whether they were ready to be closed in. And he said, gave a go for that. And so we're proceeding along our timeline to an expected liftoff at 1:30 p.m. Eastern Standard Time this afternoon. During the last few minutes, an abort advisory check was conducted. This is one of the backup systems which indicate that a major problem has been detected and the crew may have to get out quickly. This particular check involves a light which is used to signal the crew if normal voice communications have been lost. On the pad, they must open the door, get out of the orbiter, run to the slide wire baskets, and ride down the wire to the bunker or M113 armored personnel escape vehicle. The escape vehicle is positioned at the bottom of the slide wires,
Okay, just going to notify you
and
there, I guess,
the astronauts
possibly
have
flying
a
a master alarm over
choice
the
of
field.
either using that or going into the bunker.
Crew copy.
We've had an indication that because of the weather at White Sands, that the prime abort once around landing site will be Edwards Air Force Base in California. The weather at Edwards appears to be satisfactory, along with that at Dakar. However, at White Sands, which would normally be an abort once around site, they have gusts of winds up to 50 miles per hour there, and they have blowing gypsum and visibility of about 1/2 mile. Here at the Kennedy Space Center, we have beautiful conditions on the ground for launch, expecting a temperature of about 75 degrees and winds gusting up to about 15 knots. Everything going smoothly. We're standing by for the final word from the last weather balloon, but as of now, we are go. The countdown clock, T-minus 1 hour, 13 minutes, 40 seconds, and counting. This is shuttle launch control.
Okay, QC, we're going to be doing this on 145. Correction, 143. Okay, ECL, you want to go over there? ECL copies. Okay, 3-liter OTC. Go, have that crew go. Yeah, go ahead, CCSC. Crew leader, do you have an OMTO you put over there on the 143, please? In just a few minutes, we're going to finish up the latching, and we'll do the seal lid check before we start into pressurization. All right. I'll give you a holler. Thank you. OTC, this is CHCD 212. Go ahead, Gas. Okay, I'd like to advise you of this condition we've been assessing, the problem we picked up on IPR 1330. Yes. The problem appears to be an indication of talkback from the aft sample valve. If that, and it's intermittent. Okay, tell you what, has gas go 161. Okay. What's TPE? Copy. TP copy. And we got the cabin atmosphere master alarm in the cabin. Copy.
This is shuttle launch control at T-minus 1 hour, 5 minutes, and counting. The hatch on the orbiter has been closed now, and the seals checked and the latch checked, and the crew up there should be in the process now of installing the insulation plugs in the insulation. The thermal insulation in that particular area is approximately an inch thick, and the various attach points for the door must be covered to ensure that heat does not penetrate during the ascent and descent phase, primarily the descent phase. And so there are plugs which are made of insulating material, which also have threads, so they may be screwed into the points on the door where those are necessary. One of the next steps will be a pressurization test of the crew compartment and a cabin leak check. we're in the getting ready to ask the commander, Paul Weitz, to support that. Out in the SRB recovery area, approximately 165 nautical miles east, the recovery ships reported earlier that there was a fishing vessel in the area, which would have been out of the area by now, and they're in the process now of contacting a freighter and advising it to move north of the coordinate where it will be safe. This is not expected to be any problem as far as the launch is concerned. The convoy, which would support the shuttle orbiter should it have to return to the landing facility at the Kennedy Space Center, is presently being positioned to support such a contingency. The convoy is made up of a number of vehicles, including a purge truck, which flows air through the vehicle to ensure that there's no buildup of toxic gases, a cooling vehicle, which provides coolant for the electronic and other systems on board the orbiter. It's a special white room and stair truck used for astronauts to exit the vehicle. The crews are supported by scape-suited personnel who would monitor the vehicle after landing to ensure that no toxic propellants were escaping to endanger the landing support crews. Scape simply means that there's self-contained air-breathing apparatus. Everything going very smoothly in the countdown. Weather has been a concern, and we're waiting for a final weather go, which should come about the T-minus 50-minute point in the countdown. But at the present time, we have a go from the mission team and expect that that is going to stay the same. We have had to shift the once around abort site from White Sands, New Mexico to California because of the weather conditions at White Sands, where we have blowing gypsum and visibility of about 1/2 mile. Everything proceeding on time, looking for a launch at 1:30 p.m. this afternoon of STS-6, the first flight of the Orbiter Challenger. The countdown clock at T-minus 1 hour, 1 minute, 25 seconds and counting. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 55 minutes and counting. We have just completed the L-minus 80-minute weather briefing, and Launch Director Al O'Hara has indicated that we are go for launch at this time. Everything has been going very smoothly in the countdown. At the present time, the crew are getting ready for a cabin pressure check or leak check. The pre-flight calibration of the inertial measurement units has been completed, and we have now started the pre-flight alignment of the inertial measurement units. These units are used to tell the guidance systems on the orbiter where they are in relationship to the launch pad here at the Kennedy Space Center. The 3 IMUs are calibrated during the early part of the terminal countdown and then aligned for liftoff because the Earth's rotation puts errors into the system. The IMUs must be put online as part of the navigation system within about 10 minutes of completing alignment. Once they are free to measure accelerations and attitude changes, the vehicle must be launched within 200 minutes or the alignment process must be repeated. In orbit, the inertial measurement units must be realigned periodically, and this is done with the star tracker, which is mounted on the structure containing the IMUs. The astronauts make use of 2 out of 50 stars located approximately 90 degrees apart. Just a short time ago, the launch countdown clock was adjusted with the correct Greenwich Mean Time because time is a vital part of the navigational system as well. The countdown clock at T-minus 53 minutes, 8 seconds and counting. This is shuttle launch control.
CDPS OTC. This DPS. Pick up your activation of SJ6 per the clock. Okay, will do. CDR OTC. CDR, go. You can perform your cabin vent redundancy checks at this time. Go. Cabin vent ISO's closed, talk back closed. Cabin vents open, talk back open. Copy, thank you.
This is shuttle launch control at T-minus 45 minutes and counting. The S-band telemetry system has been switched to high power and configured to change to transmit and receive signals by radio rather than through wires as is done through most of the countdown. The ground launch sequencer mainline computer programs are activated and are being monitored to prepare to take over the countdown at the T-minus 9-minute point. The first crew module pressurization and leak check is complete. During the past few minutes, the range safety officer verified that the range safety system is ready for launch and is conducting an open loop command network verification test. The flight crew has configured the switch panel and activated the hydraulic auxiliary power unit's water boilers. These are used for cooling of the turbine system, which produces the hydraulic power used to steer the engine on the solid rocket motors. The countdown going very smoothly, T-minus 43 minutes, 55 seconds and counting. This is shuttle launch control. The white room, which is used for entrance by the crew into the orbiter, has now been completely reconfigured for launch and is in the stage where it may be swung back from the orbiter, which occurs at the T-minus 7-minute point in the countdown. Everything in this countdown has been moving along right on schedule or slightly ahead of schedule. We've just passed a point where one of the opportunities for Houston to update the computers. During the countdown, the 5 onboard computers are updated or loaded several times. At the 19.5-hour point, the 4 primary computers all receive the final load from the mass memory unit in the orbiter, and then all 4 are run together and the information in them compared to ensure that they all understand the same things. This is important since they act as a committee during flight and vote among themselves as to whether they are directing the flight to do the proper things. At T-minus 45 minutes, Johnson Space Center had the possibility of sending new information to update them based on any unusual weather conditions the vehicle might fly through. At T-minus 20 minute, another chance occurs to update the computers if necessary, and one of the 4 computers is read out and compared with what should be identical programs contained in the firing room data processing system console. At T-minus 18 minutes, additional opportunity occurs to input any changes. At T-minus 9 minutes, the countdown begins to be controlled by the ground launch sequencer. During this period, the ground launch sequencer sends commands to the onboard flight computers, which then report back when their tasks have been completed. At T-minus 28 seconds, the system is reversed, and the onboard computers take over the final seconds of the countdown, and the ground launch sequencer simply monitors what they've been doing. However, it does have to send a command ordering the start of the main engines. Everything going smoothly, the countdown at T-minus 37 minutes, 45 seconds and counting. This is shuttle launch control. Counting. Commander Paul Weitz has vented the cabin pressure and completed the first phase of the testing of the ability of the cabin to contain its atmosphere during the flight. Safety and security personnel here at the Kennedy Space Center have verified the shuttle landing facility has been cleared and secured in case it's needed for a return to launch site abort. In a return to launch site abort, that would only occur if we had 2 engines on the orbiter go out at a point where the orbiter was not able to actually get into orbit or complete one revolution of the Earth to land in California. In a case of that, they would have to turn the orbiter around after the solid rocket boosters have separated, turn the orbiter around and thrust backwards to slow down and then accelerate towards the Kennedy Space Center for a landing. We have just had verification from the launch director that the winds aloft are go for launch. Everything going smoothly as we move towards launch on time at 1:30 p.m. Eastern Standard Time today. The countdown, T-minus 26 minutes, 35 seconds and counting. This is shuttle launch control.
GLS? OTC, GLS? Yes, 530? Yeah, step 530 is complete. Thank you. Flight, CDR, PLT, MS1, MS2, stand by to perform simul air-to-ground voice checks. Welcome.
Challenger Houston, standing by for simul voice checks. Like to hear from the CDR first.
CDR loud and clear.
Okay, CDR is loud and clear, standing by for PLT.
PLT loud and clear.
Loud and clear, standing by for MS1.
20 seconds and counting. We're just a little less than a minute and a half away from one of our 2 built-in holds remaining in the countdown this afternoon. The primary computer program is presently being transferred to the backup computer in the orbiter to ensure that both systems have the same information. In case of the prime computer failing during flight, the backup would take over control of the shuttle vehicle. The orbiter test conductor has asked Commander Paul Weitz to close the cabin vent valves once again, and we're just about 50 seconds away now from a 10-minute build-in hold. This 10-minute build-in hold is a period during which all the computers in the firing room or the control room are configured with the proper programs for the final portion of the countdown. At the time we come out of the hold, the onboard computer will be changed over to the flight program. Also during this hold, the inertial measurement pre-flight alignment will be complete. The inertial measurement being a part of the navigation system, which is absolutely essential during flight. The countdown at T-minus 20 minutes, 13 seconds and counting, coming up on that built-in hold. Just about 6 seconds away from it. 2, 1, T-minus 20 minutes and holding. This is a 10-minute built-in hold. There will be one additional 10-minute built-in hold, which comes at the T-minus 9-minute point. Everything has gone very smoothly in the countdown since we picked it up on Wednesday afternoon. It was a 93-hour count. We had one major built-in hold that occurred from midnight on Saturday until 10 minutes after 12 early this morning. And then we've been going down. We had another hold at the T-minus 3-hour point, and then picked it up and are proceeding now towards launch. We were very concerned with the upper level winds here at the Kennedy Space Center starting last night. However, the winds have abated and we are in a go position at this time. The countdown at T-minus 20 minutes and holding. This is shuttle launch control.
CPLE verified. EPD. BCD verified. GNC and flight controls. Verified. DPS. DPS is go. CCME.
The computer transition to Ops 101 has just been made. Ops 101 is the computer program used for the ascent of the space shuttle into orbit. As we come out of the hold, the prime computer is dumped and compared with the onboard computer to verify that it has the proper configuration for launch. At this time, purge of the 3 fuel cells on board the orbiter is also underway. During this period, the flight crew will be configuring their computer for comparison tests. They have also been checking the horizontal situation displays. The crew is configuring their instruments for launch. At T-minus 16 minutes, the main propulsion subsystem cockpit switches will be configured and the helium tank isolation valves open for launch. The countdown clock at T-minus 19 minutes and counting. This is shuttle launch control.
PLT, configure pass and BFS horizontal sit displays. CCLT, roger. Go ahead, COFC. Go ahead. Yeah, 628 is verified. 629 is okay. 630. We do not meet the criteria stipulated there. That will be corrected with the patch at T-minus 9 minutes. Copy. OTC, T-minus 20-minute dump compares in progress. Thank you. VFS uplink. Stand by. BPS is ready. Thank you.
And counting. Everything going very smoothly as we count now down to the T-minus 9-minute point, where we will pause once again for a 10-minute build-in hold. The STS-6 flight is a flight having many firsts. It's the first launch of the shuttle orbiter Challenger. It's the first time we have used the lightweight external tank, the first time that we have used the lightweight solid rocket boosters. But on this mission of first, the 3 getaway specials also can claim some firsts. The one from the Park Seed Company of Greenwood, South Carolina, can lay claim to a number of them. This getaway special the getaway special program allows companies, universities, and private individuals to send scientific experiments into space aboard the space shuttle for prices ranging from about $3,000 to $10,000. The Park Seed Company is taking advantage of the program to fly the first flower and vegetable seeds into space, and also become the first company to use this program for a commercial or industrial application. Although the experiment occupies a small container, it has some broad scientific objectives. Learning to package seeds to survive the rigors of space travel and be used to provide food on manned orbiting space stations of the future is one such application. However, a much broader and vital objective will be allowing Park Seed Company scientists to learn more about the possibility of using space for storage of genetic strains which must be preserved for future generations, and the possibility of using space to produce desirable mutations in seeds. Another getaway special experiment is being flown by one of the largest newspapers of Japan. Japanese, who were the first to create artificial snowflakes on Earth, will become the first scientists to create artificial snow in space as well. The experiment, selected from 17,000 suggestions submitted by readers of Asahi Shimbun, one of the largest newspapers in Japan, with a readership of about 8 million. The experiment is expected to contribute to the knowledge of crystallography, especially the crystal growth of semiconductors and other materials from a vapor source. Semiconductors are the building blocks of most modern electric devices. Some scientists have theorized that the crystals may form of snow in a very symmetrical way, but others expect spherical crystals to form. The third getaway special is sponsored by the U.S. Air Force Academy. 6 projects were developed in an engineering design course at the Academy over the past 5 years. These experiments range from a demonstration of the feasibility of soldering beams in space to testing the effect of weightlessness on the development of microorganisms. 5 of the experiments fall in the metallurgy area, with the study of the uniformity of metal alloys manufactured in zero-G, the formation of metallic sponge, electroplating, and metal purification. The countdown continuing smoothly, the clock at T-minus 12 minutes, 30 seconds and counting. This is shuttle launch control.
bay purge rates to launch. Didn't work.
This is shuttle launch control at T-minus 10 minutes, 30 seconds, and counting. The chase plane pilots have been ordered to start their engines, and other airports in the area have been informed that the radio frequency used by the chase planes will be active through launch and asked to keep that channel clear of other traffic. The NASA test conductor has asked safety and security to verify that all non-essential personnel have cleared the launch danger area and has been assured that the closeout crews have cleared the roadblocks. The purge of fuel cells used to generate electricity on board the orbiter has been completed. The booster test conductor has started the flow of gaseous nitrogen purge of the aft skirts of the solid rocket boosters. This flow of inert gas ensures that no explosive or flammable gases can accumulate in the bottom of the solid motors prior to ignition. The countdown clock just about 35 seconds away from the final 10-minute build-in hold in our count. The flight crew has closed the vent valve on the crew cabin, and cabin pressure has been verified. The comparison of the prime computer with the onboard computer has been completed, and that is satisfactory. All aero surfaces and actuators on the orbiter are presently in the proper configuration for the auxiliary power unit to start and hydraulic pressure to be applied. 5 seconds away from our hold. T-minus 9 minutes and holding. This is a 10-minute build-in hold. The STS-6 mission is a mission of many firsts. It's the first flight of the Space Shuttle Orbiter Challenger, the first flight of the lightweight external tank, which carries the liquid hydrogen and liquid oxygen for the main engines on the orbiter. Altogether, the weight savings are significant, increasing the cargo carrying capability. 20,000 pounds altogether has been saved compared with the last launch of the Columbia orbiter. This is also the first use of the higher thrust main engines on the orbiter. They will be operating at 104% rather than 100% of rated thrust. Another first scheduled for this flight will be the exiting of the crew compartment by mission specialists Dr. Story Musgrave and Donald Peterson to spend 3.5 hours moving about the cargo bay in the cold vacuum of space. At this time, Launch Director Al O'Hara speaking to the launch crew. Countdown. Looking for a liftoff on time of STS-6, the sixth flight of the Space Shuttle, and the first flight of the Orbiter Challenger at 1:30 p.m. Eastern Standard Time. The countdown clock about 5 seconds away from picking up the count. We are holding the clock at the T-minus 9 minute point while we check on the booster system. The NASA test director is in the process of checking with the booster test conductor to determine whether or not there is a problem. Okay, we have gotten a go to pick up the clock, and we will pick up in 10 seconds at the T-minus 9-minute point. Approximately 5 seconds, 3, 2, 1, T-minus 9 minutes and counting. The launch events are now being controlled by the ground launch sequencer from now up to T-minus 25 seconds when they switch to the onboard redundant set launch sequencer. The ground launch sequencer is part of the processing system and operates by relaying commands to the orbiter's onboard computers, which then report back to the launch processing system when the commands have been executed. The primary job of the computers is to check that all of the launch commit criteria, such as propellant loads, temperatures, pressures, and other measurements, are proper. The launch and recovery director has ordered the chase planes to take off. Coming up on the 8-minute point in the countdown, T-minus 8 minutes and counting. Everything proceeding smoothly towards an on-time liftoff at 1:30. The liquid oxygen fill and drain valve in the external tank has been closed and topping of the tank completed. Liquid oxygen drain back has been started. This means that liquid oxygen is flowing through the main propulsion system and back to the large storage tank to cool the system down slowly to 270 degrees below zero, so they'll not be shocked by the torrent of super cold fluid. T-minus 7 minutes, 27 seconds and counting. At the T-minus 7-minute point, the crew access arm will retract and is in the process of retracting right now. This is the walkway used by the astronauts to get from the service structure to the orbiter. If an emergency should arise, that tower can be put back in position within 15 seconds. T-minus 7 minutes and counting. Like other things in the countdown today, we have been just slightly ahead of schedule as we go down towards a liftoff. T-minus 6 minutes, 30 seconds and counting. At the 6-minute point, the crew will perform the auxiliary power unit pre-start, which consists of positioning a number of switches and verifying that they are in the proper position, then throwing the 3 propellant isolation valve switches which allow the hydrazine fuel to start flowing from the tanks toward the APUs. Coming up on the 6-minute point, T-minus 6 minutes and counting. The pilot, Carol Bobko, has been asked to perform the APU pre-start. T-minus 5 minutes, 49 seconds and counting. T-minus 5 minutes, 40 seconds and counting. The flight recorders are on. The flight recorders provide measurements of the shuttle system performance during the entire mission for playback after landing. T-minus 5 minutes, 25 seconds and counting. Everything going smoothly towards our liftoff. And we have a go for APU start. Coming up on the 5-minute point. T-minus 5 minutes and counting. I have go for APU start. APU start is in work. The APUs, or auxiliary power units, provide hydraulic power to move the aerosurfaces and main engines for steering. The astronauts have closed their visors. T-minus 4 minutes, 30 seconds and counting. The firing circuit for the solid rocket boosters ignition and range safety destruct devices has been armed by a ground launch sequencer command. This is accomplished by a motor-driven switch called an arm and safe device. The system is then inhibited to prevent premature ignition. T-minus 4 minutes, 5 seconds and counting. The main fuel valve heaters have been turned off in preparation for engine start. The main engines on the orbiter will actually be started at the T-minus 6.8 second point. It takes 3 seconds for them to reach 90% thrust, at which time the solid motor ignition sequence starts. T-minus 3 minutes, 40 seconds and counting. The elevon, speed brake, and rudders are now being moved through a pre-programmed pattern to ensure that they're capable of doing their jobs during flight. T-minus 3 minutes, 27 seconds and counting. The shuttle is now on internal power. However, the fuel cells are still receiving some fuels from ground support equipment for another minute. T-minus 3 minutes, 13 seconds and counting. The profile checks of the aero surfaces is complete and verified, and the aero surfaces are in launch position. Coming up on the 3-minute point, T-minus 3 minutes and counting. The engine gimbal or movement check of the main engines is underway. The liquid oxygen valve for filling the external tank is closed and pressurization has begun. T-minus 2 minutes, 45 seconds. The gaseous oxygen vent arm is being retracted. T-minus 2 minutes, 30 seconds and counting. The fuel cell's ground supply of oxygen and hydrogen has been terminated and the vehicle now on its onboard supply. The beanie cap or gaseous oxygen vent arm carries away vapors from the oxygen tank while the tank is full on the pad. Coming up on the 2-minute point in our countdown, the main engines have been moved to their start position and the astronauts have cleared the caution and warning memories. T-minus 1 minute, 56 seconds, and the liquid hydrogen vent valve has been closed. Flight pressurization is underway. T-minus 1 minute, 45 seconds. At this point, the computer automatically verifies the readiness of the main engine. T-minus 1 minute, 30 seconds and counting. The liquid hydrogen tank is now reaching flight pressure in approximately 5 seconds from now. T-minus 1 minute, 20 seconds and counting. The liquid hydrogen tank is at flight pressure. Coming up on the 1-minute point in our countdown. T-minus 1 minute and counting. The firing system for the sound suppression water system is armed. T-minus 55 seconds, and the hydrogen igniters under the orbiter's engines have been armed. These devices are used to ensure any hydrogen flowing through the engines prior to engine ignition does not accumulate. T-minus 40 seconds and counting. We are just seconds away from switching command of the countdown to the onboard computers. T-minus 30 seconds and counting. We are go for auto sequence start. The hydraulic power units on the SRBs have started. T-minus 20 seconds and counting. T-minus 15, 14, 13, 12, 11, 10. We're go for main engine ignition. 7, 6. We have main engine ignition. 4, 3, 2, 1, 0, and liftoff. Liftoff of the Orbiter Challenger and the 6th flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway with our
Houston copies, Challenger.
the period of maximum aerodynamic pressure.
30 seconds elapsed. Throttles on all three main engines coming down to 81%. Velocity 2,000 feet per second. Altitude 3.5 miles. Downrange 2 miles. 1 minute elapsed. Main engine throttle is going back to 104%. Challenger is go at throttle up.
Challenger, you're go at throttle up.
Roger, go at throttle.
Trajectory slightly depressed, no problem. Flight dynamics officer reports.
Challenger, Houston, we see you're slightly depressed, no problem.
Okay, Dick.
Velocity 4,100 feet per second. Altitude 15 miles. Downrange 14 miles. Velocity 5,100 feet per second. 20 miles in altitude. Downrange 22 nautical miles. Standing by for solid rocket booster separation.
SRB-7 was that something? We got an awful lot of crud on the windows at SRB-7, Dick.
Roger, we copy that. Challenger, your first stage performance was nominal.
Okay, thank you.
Guidance has converged. Velocity now 6,000 feet per second. Altitude 31 miles. Challenger is 46 miles downrange.
Challenger, you have 2-engine tail capability.
2-engine tail.
Challenger now capable of a transatlantic abort to Dakar Airport on Africa's west coast if one main engine fails. Three minutes elapsed time. Velocity 6,800 feet per second. Altitude 39 miles. Challenger 70 miles downrange. All three main engines still at 104%. Challengers go at 3 minutes 15 seconds. Flight Director Jay Green taking a status check at all positions prior to Challenger reaching negative return point. Velocity 7,800 feet per second. 47 miles altitude.
Challenger, your negative return.
Correct, negative return.
Challenger no longer able to return to the Kennedy Space Center. Challenger is 127 miles downrange at an altitude of 50 nautical miles. Velocity 8,700 feet per second. Four minutes, 25 seconds elapsed. Velocity 9,500 feet per second. Altitudes 53.5 miles, 165 miles downrange. Challenger still go, all systems. All three main engines still at 104%. Velocity 10,400 feet per second. Altitude 55 miles. Downrange 196 nautical miles. Standing by for press to MECO.
Challenger, press to MECO.
Press to MECO, normal throttle.
That press to main engine cutoff call tells Spacecraft Commander Paul Weitz that Challenger can now continue uphill if one main engine fails. Vector J. Green, polling all positions. All controllers reporting everything looks great. 5 minutes, 40 seconds.
Challenger, you have single engine TOW capability.
Single engine TOW.
Challenger now capable of reaching Dakar Airport if two main engines fail. Velocity 13,900 feet per second. Altitude's 58 nautical miles. Downrange 321 nautical miles. Time for main engine cutoff computed for 8 minutes, 20 seconds. Velocity 15,000 feet per second. Altitude's 58 nautical miles. Downrange 364 nautical miles. 6.5 minutes elapsed time. Velocity up to 17,000 feet per second. Still at 58 nautical miles. Challenger 433 nautical miles downrange. Seven minutes elapsed time.
Challenger, your single engine press to MECO.
Single engine press, thank you.
That call tells the crew to press on even if two main engines shut down early. Challenger's velocity nearing 20,000 feet per second. 529 miles downrange at an altitude of 58.1 nautical miles. Main engine cutoff still computed for 8 minutes, 20 seconds. $23,000 feet per second. Altitude's 58.5 miles. Downrange 629 nautical miles. 8 minutes.
Master alarm, cabin atmosphere light, Houston.
We copy.
Cabin atmosphere master alarm. $25,000 feet per second.
MECO. We got a MECO.
Roger, we copy, and no problem with your cabin atmosphere.
Nominal MECO.
Roger.
Houston confirms external tank separation.
We don't have 104 yet, Houston.
Roger, we copy. Challenger, we need for you to switch aft bay 1 fan.
Okay, how about Ops 104, Dick?
And Challenger, recommend manual pro to Ops 104.
Ohms 1 will be 223 feet per second. Burn time 2 minutes, 26 seconds. Looking for an orbit of 153 by 50 nautical miles.
Go for nominal Ohms 1. APU shut down on time.
Go, Houston.
Ignition both engines. Good ohms burn. We're 30 seconds away from loss of signal through Bermuda. Ohms burn continuing in good shape.
Challenger Houston, we're 20 seconds to LOS. We see a good burn in progress. Configure LOS. We'll talk with you at Dakar at 17.
This is Shuttle Control. Bermuda has had loss of signal with Challenger. Next acquisition through Dakar in approximately 6 minutes.
We are go for auto sequence start. The hydraulic power units on the SRBs have started. T-minus 20 seconds and counting. T-minus 15, 14, 13, 12, 11, 10. We are go for main engine ignition. 7, 6. We have main engine ignition. 4, 3, 2, 1, 0, and liftoff. Liftoff of the orbiter Challenger and the 6th flight of the space shuttle. The shuttle has cleared the tower.
Challenger's underway with our program.
Houston copies, Challenger.
The period of maximum aerodynamic pressure. "30 seconds elapsed. Throttles on all three main engines coming down to 81%. Velocity 2,000 feet per second. Altitude 3.5 miles. Downrange 2 miles. 1 minute elapsed. Main engine throttle is going back to 104%. Challenger is go at throttle up.
Challenger, you're go at throttle up.
Roger, go at throttle.
Trajectory slightly depressed, no problem. Flight dynamics officer reports.
Challenger Houston, we see you're slightly depressed. No problem.
Okay, Dick.
Velocity 4,100 feet per second. Altitude 15 miles. Downrange 14 miles. Velocity 5,100 feet per second. 20 miles in altitude. Downrange 22 nautical miles. Standing by for solid rocket booster separation.
SRB-7 was that something. We got an awful lot of crud on the windows at SRB-7, Dick.
Roger, we copy that. Challenger, your first stage performance was nominal.
Okay, thank you.
Guidance has converged. Velocity now 6,000 feet per second. Altitude 31 miles. Challenger's 46 miles downrange.
Challenger, you have 2-engine TOW capability.
2-engine TOW.
Challenger now capable of a transatlantic abort to Dakar Airport on Africa's west coast if one main engine fails. Three minutes elapsed time. Velocity 6,800 feet per second. Altitude 39 miles. Challenger 70 miles downrange. All three main engines still at 104%. Challengers go at 3 minutes 15 seconds.
Go for main engine ignition. 7, 6. We have main engine ignition. 4, 3, 2, 1, 0, and liftoff. Liftoff of the Orbiter Challenger and the 6th flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway. We got
Houston copies, Challenger.
Period of maximum aerodynamic pressure. Thirty seconds elapsed. Throttles on all three main engines coming down to 81%. Velocity 2,000 feet per second. Altitude 3.5 miles. Downrange 2 miles. 1 minute elapsed. Main engine throttle is going back to 104%. Challenger is go at throttle up.
Challenger, you're go at throttle up.
Roger, go at throttle.
Trajectory slightly depressed, no problem. Flight dynamics officer reports.
Challenger, Houston, we see you're slightly depressed, no problem.
Okay, Dick.
Velocity 4,100 feet per second. Altitude 15 miles. Downrange 14 miles. Velocity 5,100 feet per second. 20 miles in altitude.
13, 12, 11, 10. We're go for main engine ignition. 7, 6. We have main engine ignition. 4, 3, 2, 1, 0, and liftoff. Liftoff of the Orbiter Challenger and the 6th flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway. We got
Houston copies, Challenger.
Period of maximum aerodynamic pressure. 30 seconds elapsed. Throttles on all three main engines coming down to 81%. Velocity 2,000 feet per second. Altitude 3.5 miles. Downrange 2 miles. 1 minute elapsed. Main engine throttle is going back to 104%. Challenger is go at throttle up.
Challenger, you're go at throttle up.
Roger, go at throttle.
Trajectory slightly depressed, no problem. Flight dynamics officer reports.
Challenger, Houston, we see you're slightly depressed, no problem.
Okay, Dick.
Velocity 4,100 feet per second. Altitude 15 miles. Downrange 14 miles. Velocity 5,100 feet per second. 20 miles in altitude. Downrange 22 nautical miles. Standing by for solid rocket booster separation.
SRB-7 was that something. We got an awful lot of crud on the windows at SRB-7, Dick.
Roger, we copy that. Challenger, your first day's performance was nominal.
Okay, thank you.
Guidance has converged. Velocity now 6,000 feet per second. Altitude 31 miles. Challenger's 46 miles downrange.